If you are registered for AU Postutme, there are some specific topics you will need to know before you write AU Postutme exam. So these are the things we really want to quickly talk about in this episode. And welcome back to my YouTube channel. Thanks for always sticking around. Now, I need to tell you about some things in chemistry in this episode. Some topics in chemistry that your teachers might have not covered when you were in secondary school, or even when you read for JAM. Probably you didn't cover all these topics. I would like you to know that you might ask you questions in this area I'm likely to talk about based on the experience and based on what we have seen so far. Now, where you might like to ask you questions here, and I've spoken with many students, they have issues with some of these topics, and one way or the other you just need to know. So in the next 1 month when you will be writing your exam, you need to understand some of these topics deeply. You might not have all the time now to go through the entire topic, to go through the entire syllabus, but at least have idea about some specific things I'm about to say. There are some specific aspects of each topic that you really need to know. So there is a general idea that even if you read for JAMB and you scored above 200, definitely you have those ideas. So why will you not write AU Postutme? AU Postutme goes beyond secondary school experience, because AU wants the best out of their students. So, and these are the things that some of your teachers might have actually spoken about, but since when you solve most of your past questions, you don't really see questions related to those things, so you didn't really take notice of those things. So let's just talk about them now. Fine, to start with, you can read the entire syllabus in chemistry and OAU will give you just 10 questions. So it's funny. That means you have to cover the entire syllabus and cover it very, very well, because when you have 50 questions, you might still gamble around and score 25, score 30, score 40. But when you have 10, it's either you know or you don't know. So that's where the problem is. Now, some people can score 10, whereas some people might score 0 over 10. Some people can score 2 over 10. Now, you know, if scoring 2 over 10 can cost you a lot. So that's why we're putting this out, that okay, let's just try and know about everything we need to know. You must have been reading, I know, but let's now see, maybe you've not touched some of these aspects. So let's discuss it in a couple of minutes. Now, when you are dealing with chemistry, I know the first topic is matter and the criteria for purity, and all. At least you need to know the general idea of criteria for purity, and you must be able to apply. When they give you compound A, compound B, give you some specific temperature, you must be able to differentiate if one is pure or one is not pure, what would be their boiling point or melting point range, depending on the compound you're talking about. Then another thing is periodicity. You must not only know how to determine the group, period, and blocks, the names of the groups. You must also be able to talk about, you might know all the physical properties like the atomic radius, ionization energy, electron affinity, and so on. But the reasons for the trend in those properties, you need to know them deeply. Then you need to know your first ionization energy, second ionization energy, third, and you must be able to write equation for each of those ionization energies. So when they ask you a question, you must be able to tell what energy is responsible at a particular time when the electron was removed. So one of those things you need to just take note of. They are very simple, but most times students don't take note. Then students don't even know how to write half equation. So you need to understand that I might write one equation and it might be wrong, and it might almost mean the same. So you need to understand how that operates. Now, you must know the trend, that is the reasons for those trends. What are the reasons? Like the nuclear charge, the screening effect, the distance to the nucleus, all those things are affecting the properties. So you must know deeply, because this goes a long way to tell you more about how you actually understand your chemistry. So now the next topic you need to know is atomic structure. When you are dealing with atomic structure, you know everything about proton, electron, neutron, and the common things, the properties, and all. But you must know the atomic model very well. You must know the work the scientists did to discover many things on the in dealing with atomic structure. So you must know most of those works the scientists did, the atomic model. Then when you leave that chapter, you must quickly also know how to write configuration for the transition element when they lose electron. There are some questions they can ask you that how many unpaired electron is present in copper 2+. You must know that copper 2+ will lose 2 electrons first in the 4s, not in the d orbital. So how they lose their electron, if they ask you the number of unpaired electron, you must be able to determine that. Now you must also be able to determine the 4 quantum numbers accurately. You must be able to describe the 4 quantum numbers accurately. Another thing is that even though you know that this is principal quantum number, this is azimuthal quantum number, this is magnetic quantum number, what other name do you call them? For example, now azimuthal quantum number is also known as secondary or subsidiary quantum number. What other name? So these are the things where you text, where you know your general knowledge, the things you know. But there are some other names they call most of those things that you don't deal with. After this, I will also deal with the biology and the physics if you want me to. I will analyze each of the topics you really need to know and you really need to learn before the exam. And even if you want us to teach some of these topics, you can leave a comment in the section below to let me know that okay, I should teach you a particular topic. I'll quickly make a video on those topics so we treat some questions all together, then you deal with it before you go for your exam. Then when you have described the quantum numbers, remember your principal quantum number and describing the electronic shell, azimuthal dividing those shells into orbitals, all those values, azimuthal having a value of 0 to n-1, the magnetic having a value of -L through 0 to +L, then spin, you know, that's just a general plus or minus 1/2. Now when you are dealing with those quantum numbers, you must use them to determine many things about the atoms, like probably determining the atomic number, probably determine what elements you are really dealing with when you see the principal quantum number and the azimuthal quantum number, probably determine the block, the shell, a whole lot of things using the quantum numbers. So you must be able to do those calculations, not all those spherical, P dumbbell, double dumbbell, and so on. So you must know a bit about it. So quickly go through most of those things. Then the next thing is kinetic theory. Just know the things about kinetic theory. Must be able to differentiate deeply between ideal gas and real gases, and you must be able to draw different graphs, not the common graphs of P inversely related to 1/V that you have your curve like this. You can have several graphs. You can have PV related to your constant, you can have PV related to N, you can have PV related to the number of moles. You can have same thing for Charles' law, for Boyle's law. No another name for Boyle's law. I think one of the questions I asked last year. So most of these things you need to know about them. So the next thing is chemical bonding. Chemical bonding is one of the most important topics that I see that is important whenever you is asking questions. Where you ask a lot of questions on chemical bonding, because we take chemical bonding for granted. Maybe I should say that. Now, because there are some deep things you need to know. Intermolecular forces, you must be able to deal with them properly. The Van der Waals forces. When you see a molecule, you must know the type of force that is within the molecule. You must know how to deal with hydrogen bonding very well. So the different types of Van der Waals forces, the London dispersion force, the dipole, the induced dipole, all these, how they work, you must be able to talk about how they work when you see a compound. Practicality of it is very important to you, more than you just understanding the theories and being able to state and all. Then you remember the normal interatomic bonding, like all your normal what's it called, covalent, electrovalent, their properties, coordinates, you know all those ones, right? So just try and deal with your intermolecular very well and apply. Pick a molecule, look at the type of intermolecular force that is present in such molecule. So another thing you must know on chemical bonding is hybridization. You must be able to deal with the different hybridization of central atom when you have atom with a group of atoms around it. So you must be able to determine the hybridization of that atom. And when you have determined the hybridization of that atom, you must be able to talk about the overlapping orbitals as well. For example now, if I have CH4, in CH4 the hybridization of carbon is sp3, that of hydrogen is in s orbital. So the s orbital of hydrogen overlaps with sp3 and hybridized orbital for carbon. So you must be able to determine the hybridization in most of those atoms. Another thing you must know is how do you determine the percentage of the S, we call it S character and P character. You must be able to determine that as well. Then you must be able to deal with separ theory. Separ theory is known as valence shell electron pair repulsion theory. So you must be able to talk about the arrangement of those electron pairs around the central atom, how it determines the shape of the atom and many other things. The lone pair, the effects of the lone pair, the effects of the bond pair. So you must know how to deal with all these things. They are very, very important when you are dealing with them. Then another thing you need to know aside the separ theory is you being able to deal with the Fajan's rule. Yes, Fajan's rule is also important. The Fajan's rule deals with the covalent character and ionic character. So if I give you a list of compounds and I tell you to tell me which one is most ionic, if you know Fajan's rule, you'll be able to determine that. These are common things, but it's just that oftentimes students see them like, oh wow, they're about to kill me. No, you're not going to die. All you just have to do is read a bit about them. So there's nothing much in dealing with those things. You must be able to determine polarity as well. I can give you several molecules and determine which one is polar, which one is non-polar. So there are several questions they can ask you on chemical bonding. But in addition to your general knowledge of chemical bonding, make sure you know these things I've talked about. You can do them within a couple of days, within a couple of weeks. If you are wise enough, you will know what to do. Now, the next topic you need to also deal with is stoichiometry. You know the general mass to mass relationship, mass to volume relationship and all. You must know how to deal with molarity, molality, normality. You must be able to talk about the limiting and excess reagents. You must know what we call percentage purity and percentage impurity. You must also know how to deal with percentage yield. So percentage yield being the ratio of your actual yield over theoretical yield multiplied by 100. These are questions we've seen before in OAU Postutme past questions. So deal with them sincerely. OAU do most of these things to select the best and brilliant students, and I can proudly say that most students that graduate from OAU, although many people always say it's like, oh damn, it's a kind of stress going through OAU, they choke us with a whole lot of things. So you avoid tsunami. They don't want you to get to the board and you see F down the board when you're checking all your results. When I was in OAU, then we call it tsunami, mass failure. So you don't really want that in school when you're having your students. And when you go through some selective processing, you deal with some ways in which you can select students based on their level of intelligence. Then you also avoid mass failure. So one of those things I see in the technicality of OAU Postutme. But if you know how to prepare well, you know how to read well, you're definitely going to pass. So, and I'm sorry, I also need to congratulate you because I know scoring above 200 in JAMB must have qualified you for this. But when you're going to OAU, you have to understand that if you all score 200, you are qualified to write Postutme. But the 200 does not qualify you for admission. So you can check through the previous video. I've analyzed some of the cutoff marks, and I've also analyzed how you can do your calculations on the Postutme grading system. So I've talked about most of those things in the previous videos. So now, leaving stoichiometry, the next topic, don't forget you must know how to differentiate between molecularity of reaction. You must also be able to at least write ionic equation and all. So the next thing you need to know is acid base and salts, like the theories of acid base and salts. Use the Lewis theory and the Bronsted-Lowry theory to determine many things about the acids and base. Then you must be able to talk about solution, suspension, colloids, differentiate them, then solubility, factor factors affecting solubility of a compound, then the solubility product constant, and common ion effects. So you must know those things at least. These are some things I'm very sure you didn't deal with them when you were in secondary school, like the common ion effect. It's a very simple technique, and you can apply it to your equilibrium system and see how things go. When you add a salt with common ion, does it affect the solubility? Does the solubility decrease or the solubility increases? So you must be able to tell some of these things. Then another thing is, when you leave acid, base, and salt, when you leave this aspect, you must be able to talk about redox reaction properly and relate it to electrochemistry, the E naught of the cell, determining spontaneity, how you do basic calculations on E naught. You must know the rules on how you do that. And in the electrochemical series, ions above hydrogen always carry negative E naught reduction potential, and most of these, the more the negative E naught reduction potential, the easier it is for that ion or that atom to lose electrons. So there are many things you have to understand on how that works, on how that operates, and you must be able to relate them when you're talking about spontaneity of a reaction, or when you're doing some bit of calculations. You can also know the introduction to the next equation. So how the next equation helps you to do some bit of calculation for the EMF of a cell, if or not under standard condition. So you must be able to deal with that. Then another thing you must be able to deal with is chemical equilibrium. Now, chemical equilibrium, you know the general stories of chemical equilibrium, the Le Chatelier's principles, the factors affecting equilibrium system, but you must know the properties of K. I think that's the area where students have issues with the most. The properties of K, the equilibrium constant. How does the K affect the K being the equilibrium constant? There are some things that affect K. There are some properties of K, like K forward and K reverse, they are multiplicative inverse. You must know that. Then when you have an equation of an equilibrium system, then you have that equation multiplied by a value, maybe a coefficient or something. Let's say you multiply by 2. Then the K for the first reaction must be raised to the power of 2. If you multiply the equation through by 2, the K for the next reaction must be raised to the power of 2 in order for you to calculate the equilibrium constant for that K. So all these things, you must be able to relate them. So there are some specific textbooks you can quickly go through to understand most of these things. So, and if you want me to teach them, please leave a comment in the section below. I will definitely find time quickly this week to teach you, and do as well to share with every other person, so that they can please go through these things and see where they have issues and where they want us to treat some of these topics for them quickly before the exam. And let's just pray that at the end we all have testimonies. We want you all to succeed. So now when you leave chemical equilibrium, you move on to chemical kinetics. Chemical kinetics, you know the general thing, factors affecting rate of chemical reaction and all these things. But you must also be able to deal with rate law, dealing with the order of reaction. How does increase in concentration affect the rate of reaction? The rate of reaction increase or decrease by what factor, depending on the order of the reaction. So you must be able to deal with order of reaction. You have the zero order, first order, second order, third order, and so on. Then you must be able to draw their graphs. So dealing with this aspect very well shows that, okay, you have some bit of understanding of chemistry and chemical kinetics. Now when you leave that aspect, you must be able to talk about heat changes. When you're dealing with heat changes, you must know the relationship between delta S, delta H, and what's it called? Delta G. Delta S, delta H, delta G, the relationship, how you use them to determine the spontaneity of a reaction. When delta S is greater than 0 and when delta H is less than 0, your reaction is always going to be spontaneous at every temperature. So you must know these relationships. You can put values to check them out. Is this true? Is this not true? Like, at least to some extent, deal with them very well. Even there are some part of it that probably Lamla didn't treat for you when you are talking about these topics. But if you have LAMLAD is a very good textbook that you can also go through some things in order to, but you also need some bit of knowledge to add to your LAMLAD when you are dealing with them. I know you probably read LAMLAD and these books during your JAM preparation. You should by now, you should know, like we always say, pali to pali. So you should know from beginning to the end of LAMLAD by now. It should already be part of you. Then when you deal with its changes, try and know the Hess's law calculation, basic Hess's law calculation that you can quickly do even when you don't have that giant calculator. You can quickly do them. So the summation, Hess's law summation, you must know the bond dissociation, bond forming energy, and all these things, how you relate them to reaction. So how all these things work, you can also have idea of the law of thermodynamics, so the law of thermochemistry. Then when you're done dealing with Hess's law, it's very important to understand qualitative analysis, how you determine some specific cations and some specific anions that are present in your reaction system. So you must be able to at least do that. Talk about some precipitating reagents, look at the solubility of salt, look at the colors the anions can give you, the colors the cations can give you in solution, look at the reagents you use to test for these cations and anions as well. So you must be able to deal with that as well. Now another thing you need to know is the organic. The inorganic is important. You can know the compounds of nitrogen and nitrogen. You can know the compounds of carbon, sulfur, compounds of hydrogen, and the halogens. You must be able to deal with them very well. Then the general introduction to metals and non-metals. So know all those things that are very, very important there that you can quickly brush through and deal with. Then your organic chemistry, there is a general knowledge of organic chemistry that you need to know, but in secondary school I can bet that there are some of these things you actually didn't talk about, but they are the introduction to organic chemistry and you really need them. So you need to understand the general chemical properties of organic chemistry. You must know the general chemical properties that differentiates each family. Then you must also know the general physical properties, like dealing with the volatility, solubility, boiling point, and all these things, and the factors that affect those general physical properties. You must also be able to tell the nature of your reaction, homolytic and heterolytic reaction. You must be able to differentiate. You must be able to differentiate or say more about iodoform reaction, ozonolysis reaction. All these reactions are very, very important that you must be able to talk about, and some bit of mechanisms about how these reactions happen. So not really mechanisms per se, but at least the steps on which the reactions happen, because you might not understand some deep mechanisms of how reaction operates, but at least to some extent know some things about how it happens. The photolytic substitution of alkane as well, know about that. So not just know the products, not just know how things operate, know the catalysts involved in most reactions, know how it's all operates, how it's all work, know Markovnikov's rule very well, know every rules that are important in organic chemistry, all those important general things, at least know about them. So not just deal with I know alkanes they undergoes substitution reaction, this and that. Fine, you know that, but there are some things that differentiate them more. So try and know all these things. Then you must also know what we call a nucleophile and an electrophile. So you must be able to deal with a nucleophile and an electrophile. All these ones gives your knowledge, how you understand many things about your organic chemistry. If you have any issue on all these aspects, you can let me know what we can do. Then another thing you need to know is double bond equivalence, how you can determine the unsaturation in an organic compound. You need to know that. The retention factor values, you can also determine that when you're talking about chromatographic analysis. So you must be able to do that basic calculation as well. So these are the most important things you need to deal with in chemistry. If there's any of this topic you really want me to teach you within the couple of weeks before your exam, please do well to let me know in the comment section. And if there's any of your friends that are writing with you, please endeavor to share with them. Share the information. Let the people that can work, let them get the benefits of it. So let them see it, let them read, let them work so hard. then you are definitely going to be alright. So you all should work together, and don't forget to give me the thumbs up. Don't forget to subscribe to my channel. I'll be bringing you more content on how you can do well in school and some aspects of lifestyle as well. So I'll be telling you more about it. So put everything all through together, and I know God will see you through. God written. So just do your best, and please share, comment, and like with your friends. So thank you so much. God bless you. I'll see you in OAU. I'll come for your matric. I know that. So just invite me. I'll show up for your matriculation. I'm sincere about it.